allocated, and now we were opening this sector, we were parsing NTFS file system to find out which sectors correspond to page file. Then we are searching those sectors, and we override the first 24 bytes of the function with our shellcode. It took 23 bytes to come up with this very simple shellcode, which overrides this global variable. And we try to load debug view again, and we get it working. Question?
I think that's one more challenge.
Say it again.
I think that's one more challenge. How do you make sure when you are modifying the page file, it's not getting changed by the operating system?
There's no reason for operating system to change paged out code of the driver, right?
But maybe at the same time, the operating system is loading some driver and get something else back to the page file. For example, operating system.
It doesn't matter if it loads something else from page file. We only. Okay, the question was, what happens when the operating system changes page file at the same time when we are trying to modify it? Because we modify page file by raw disk access, and operating system access page file by some other means. But it doesn't matter because we modify only one physical sector of the disk, so we don't care what happens on the other disk sectors. And there is like very, very, very little probability, almost zero, that the system would like to modify the page, the disk sector which contains the code of this very dispatch driver function which I'm modifying, because there is no reason for the operating system to modify the paged code section, right? Okay. Maybe I will just finish this first part. We'll have like 2 minutes for questions, and then we go to the second part, okay? Because I would like to tell about possible solutions to this problem right now. I see 3 solutions to this problem. Solution number 1: forbid raw disk access for user mod applications, right? So that create file bracket //./c : will not work anymore. Of course, this will break compatibility because, well, as I said, this is a documented way. It's described in a SDK. So it's not a good way. Of course, it will break probably many applications like disk editors and deleters, some probably antivirus programs, some databases maybe. And if Microsoft did this, then I could imagine that creators of those applications like disk editors or whatever would come up with their own kernel mod drivers for allowing access to those raw disk sectors, which would read, and of course those drivers would have to be signed, right? So then it would be nothing which would stop attackers from just copying those drivers and using them just like disk editor is using them, right? It just would be necessary to reverse engineer the interface between user mod application and their custom kernel mod driver. So this is very, very bad solution. I don't recommend it. Solution number 2 is to encrypt page file. Once we get the page file encrypted, it wouldn't be possible for the application to find and modify in an interesting way the kernel code which is there. There might be some, well, I expect a big performance impact if this was implemented. And actually, I just yesterday talked to some Microsoft person, and he told me that it is actually possible to turn on page file encrypting in Vista. I think it was introduced in Vista Beta 1 or something like this. So there's a registry key which says enable page file encryption, and this is used, of course, for not for preventing this kind of attack. This is used for this encrypting Diskkeeper, whatever, Bitdefender. I don't know what the performance impact is of this, and I believe it encrypts all the page files. So not only kernel code which is paged, but also user mod code. So I would expect a big performance impact of this. Solution number 3 is to disable kernel mod paging, because today we have lots of memory, lots of physical memory, and the amount of all the memory which is pageable in kernel code is around like 70 megabytes. So when we have like 1 gigabyte or like 4 gigabytes of memory, those 70 bytes is really It's just nothing, right? So personally, I would recommend just to disable paging of kernel code and data, right? So this pageable pool should become non-pageable pool. And again, you can actually manually disable kernel code paging in registry. And yeah, that's what I'm doing for my home machine. Just because I have 4 gigabytes, so it doesn't really make any sense to have paging enabled. But it's quite interesting to notice that those two solutions, like to enable encryption of the page file and to disable paging, they still allow for bypassing this Microsoft policy because Microsoft said in their paper about driver signing that it shouldn't be possible to turn off this mechanism permanently. Only 2 ways are allowed: pressing F8 every time the system boots, or attaching kernel debugger every time the system boots. But even if we had a smart user who disabled paging, we still can enable it, reboot the system, and then it's gone, right, forever. So of course it's not that cool as this attack I just showed, which doesn't require reboot, but it's still something which bypasses Microsoft policy. So in my opinion, this should be hard-coded, right? Just disable paging forever. Okay, so this is the first part. So the prison attack doesn't rely on any implementation bug. It also doesn't require any undocumented functionality. Create file is perfectly documented thing. I think Microsoft did a good job with this mechanism. It's a little step forward into securing kernel. It's just, it's just very. It doesn't mean that Vista is so unsecure. It just means that it's just not that easy to turn the generic operating system into a very secure one. Okay, so just before we go to the part 2, some questions. Okay, yeah. Say it again.
The access control list, ACL.
Uh-huh.
They put one on the page file. So the page file. Great. So the page file can only be accessed by the system instead of by user mode. Wouldn't that prevent you from being able to read the page file from a user mode program?
No, but you cannot prevent it because if you allow raw disk sector access, because the ACL on raw disk access is to allow administrator to read it.
Yes, you're correct.
Yeah. Okay. Okay. About UAC, yeah. All right. The question was how I got around user account control. Well, I just pressed accept. The command prompt, yeah. This. I'm not bypassing UAC, okay? So on the demo, I just opened this console as admin. I said run as administrator and just press accept. Bypassing UAC is another thing, and UAC is another good step towards securing kernel. But from my experience is that all the Vista users are complaining about UAC because it pops up every 5 minutes and they automatically press accept, right? So I would expect that if somebody downloads some malware or gets it as an attachment, and after running it, it will display this consent dialog box, most of them will just press it. But bypassing user account control is another thing which is interesting and is not covered here. Last question for this, okay?
What about encryption of the volume with the BitLocker?
I haven't checked it, but as far as I understand this technology, it is to prevent somebody others who steal our laptop or whatever to read it. It's not to prevent administrator from reading his files, right? Because yeah, but I know the key, right? The decryption key as administrator. So I would expect that this encryption, which is here, because if there was, I would expect that this encryption, which I told about using this with this solution number 2, this is what can stop it, because the key is kept in kernel. Why this keeper is about what's the name? Bitdefender, BitLocker. Oh yeah. BitLocker is about preventing others and not administrator from eating it. But I haven't tested.
Okay. I don't know, in fact, if the administrator has any simple means of accessing the key BitLocker is using to encrypt the volume, so I don't know the answer either.
Okay, so somebody needs to test it. Okay, I think we will go to part number 2. Okay, one more question. From user mode. No, as I said, you need to have administrator access for this. Can you say it again?
So if you call create file from any user mode program, null.sys gets loaded into the kernel back from the page file?
If you call create file from any process which has administrator rights, it can get access to routed sectors.
Oh, so you're using create file to write to those sectors, right? To write the data.
Create file returns handle, and then I use write file.
Right. So, but what are you using to make sure that the modified code from the page file gets loaded back into memory?
To modify what?
After you modify the page file, how do you make sure that that code is actually executed?
Oh, as I said, because I call, well, create file is used for 2 things here.
Okay.
First thing is to create file is to first to get access to routed sectors to find those bytes in page file, and the other thing is that create file is used to open device object created by this kernel driver, which I am exploiting. And this actually makes kernel to call this code.
Thank you.
Okay, one more question.
In your testing scenario which you showed us, do you have page file on the system volume? Because I don't believe it's possible to open the raw disk for write. You have to lock it.
No, you don't have to. You can open. No, it was normal. It was standard installation of Vista. Nothing was disabled or enabled, especially. Because the question was, how was it possible to get access to page file, although it was opened by kernel, right? So with this no share flag, but we bypass it because we are accessing routed sectors. So as you've seen on this presentation, I was opening master boot record, and I was parsing NTFS information to find out which sectors contain this page file actually. So I was not opening pagefile.sys. I was opening routed sectors. Okay, so let's go to the part number 2, which is about abusing SVM technology for creating undetectable malware. What we have today in rootkit field is that we have something I call invisibility by obscurity. For example, FU by Jamie Butler works by unlinking, or Futu by unlinking some kernel objects from some kernel lists, which makes them unavailable for